Good morning, everyone. Thanks for being here. Today, I'd like to talk about new features of multi-node server management. Um, Let me introduce myself first. My name is Bonnie, and I'm a technical manager at Wiwynn Corporation. I'm working on OpenBMC and OpenBig firmware development and focus on the firmware architecture design for all kinds of server and storage product. You can see the outline of my presentation. I will briefly introduce our hardware and software architecture. And today, my focus will be on three new features of multi-node server. The first one is cable detection, and the second one is validation update. And the last one is DDR5 PMIC error injection and reporting. Okay, let's start with the hardware architecture overview. This is a 4OU system. There is a base board connect with 4 server board, and the base board is the primary management board of the platform. So BMC is on the base board and tech responsible for gathering all the system information. The bridge IC, which is also a management controller, is on the server board to communicate with CPU, DIMM, VR, and other devices on the server board. Also, which is to communicate with connected expansion card. Okay, and this page shows several hardware configuration type. The config A is our typical type. BMC is on the base board and connect with 4 server board. And the bridge IC is on the server board. For the config B, the base board connects with 2 server board, and each server board can connect with 2 2OU extensible 8-on card. And the config C contains 4 server board. Each server board can connect with a 1OU expansion card. The difference between config A and the config C is the 1OU expansion option. So all in all, BMC is on the base board and connect with individual server module with cables to support various of configurations. Next, let's get started. Overview the management controller architecture. The base board has an OCP NIC card. So BMC obtained its network access through the OCP NIC card by NCSI connection. So end user can communicate with BMC through the network. We provide different kind of user interface, such as IPMI out-of-band command, REST API, and some SSH command. Then BMC can communicate with server board big by IPMB command. And if the SKU has 1OU, 2OU, or any other expansion card, big on card can send the information back to the server board big, and then the server board big can pass the information to BMC. And BMC will report the information to the end user. Okay, the BMC on the base board is the primary management controller of the platform. So functions of BMC on base board are including sensor monitoring, error reporting, firmware update, and power control. And BMC, it can receive the information from the bridge IC and report to the end user. And the other table shows the management controller on the server board and expansion card. The server board contains the CPU subsystem, so functions of the bridge IC on the server board are focusing on the server board management and CPU host related management. And functions of the bridge IC on the expansion card include the hardware management of CXL and the power on sequence control. Wiwynn has joined the firmware development of OpenBMC and OpenBig for a few years. Here are the source links. We devoted to developing several storage and server products. For the storage product, we've developed a JBUF with Gen 3 PCIe switch and some storage server with Gen 3, Gen 4 expander. And for the server product, we've developed a 2-socket server with Pearly platform and some multi-node server with Grantley, Wheatley, and now EagleStream platform. Now we are going to show our management challenges. First one is the cable unplug and cable mismatch. The cable between the bus board and the server board includes some low-speed signals such as I3C, alert signal, power enable signal, and fault signal. The left picture shows the correct cable connection. Here's an example. There are 4 cables from the bus board, which is connected with the server board one by one. And the right picture shows some error cases. The first one is cable unplugged. In this picture, you can see that there is no cable connection between cable 1 and server 1. In this situation, BMC cannot communicate with server board correctly. And the other one is cable mismatch. As you can see, the cable 3 from the bus board connects with the server 2, and the cable 2 from the bus board connects with server 3. We can detect this kind of wrong cable connection and has an event log record for about 2 error cases. Then I will show all the cable detection event record for all the situation. So the first one, if the cable connects with each other correctly, BMC shows that slot present. So here is an example to show that slot 1 to slot 4 present. And the next one is if cable does not connect with its corresponding server board, BMC shows an abnormal event that slot 2 instead of slot 3 and slot 3 instead of slot 2 in this example. So here is the log shows that slot 2 and slot 3 are cable mismatches. Next one is if cable is not connected with the bus board, as you can see the green cables, BMC shows that slot 4 cable is not connected to the bus board. And if cable is not connected with the server board, as you can see the black cable, BMC shows that an abnormal event that slot 1 not detected. So this page shows about 2 error cases. The The left one shows cable is not connected with the baseboard, and the right one shows the cable is not connected with the server board. The second management challenge is firmware misupdate. The challenge is that PIC is on the both server board and 10U card. There is a risk to flash the wrong big firmware to the board, which might cause big firmware malfunction. In addition, CPLD is on server board and baseboard. So, and CPLD tag responsible for controlling the power on sequence. So if the incorrect instance is updated, which means the GPIO, SGPIO, any IO function in CPLD firmware are entirely wrong, which might cause server board power on fail and malfunction. It's a critical issue in data centers. So to prevent this kind of firmware misupdate, we design a validation update flow. Here is our validation update flow. There is a firmware update utility in BMC, which can be set as force mode or normal mode. If it goes with force mode, which means we want to update the image no matter what the situation it is. Therefore, BMC will not do the validation. If it goes with the normal mode, BMC perform the validation of the image. So firstly, we will check the image size. The image should contain the original image and the validation update region. Secondly, we will calculate the MD5 checksum. The MD5 checksum is to confirm the integrity of the image. And thirdly, the playphone name. The playphone name in the validation update region should be matched as we define for each playphone. And the last one is error proof. We'll have 3-byte error proof to indicate the board ID, through stage, and the firmware component. I will show the layout of the validation update region to explain the information I mentioned above. So yeah, firmware image containing the validation update region and the original image. Here is the layout of the validation update region. So first, we will calculate 2 MD5 checksum. The first one is to confirm the integrity of the original image. And the second one is to confirm the integrity of the validation update region. And next, we will have 16-byte ASCII format of playphone name. The playphone name should be matched as we define for the playphone. And next one is the 13-byte firmware file version to that BMC know the image file version. And the last one is error proof. There are 3-byte error proof which contain 4 kinds of identification, which are board ID, component ID, through stage, and instance ID. First one is the board ID. The board ID is to identify the target board, which I show in this table. So including the server board, baseboard, NIC's expansion board, or any other type of 10U card. And the second one is the component ID. The component ID is to identify the component is CPLD, big, or bias. And next one is the through stage. The through stage is very useful during the firmware development because we might have compatible issue between hardware and firmware. And currently, the instance ID is reserved. Okay, the last topic I want to talk is about DDR5 PMIC arrow injection and reporting. PMICs allow features like threshold protection, error injection, programmable power on sequence, and power management features. And we focus on the PMIC arrows because BMC should record the PMIC arrow correctly. And the PMIC arrow includes some threshold event and some MISC events such as a high temperature warning, power good status event, and high current or current limit warning event. So we implement dim util as a utility in the BMC to do the arrow injection and get the arrow status from each of dim. So here is an example to show that we inject a high temperature warning arrow to dim A0. And then we use the dim util to get the arrow status from each of dim, and it shows what kind of arrow. So dim A0 shows a high temperature warning. And BMC record a dim A0 high temperature warning event as well. Yeah, so let's talk about PMIC arrow event logging mechanism. Before BIOS post complete, BIOS read the PMIC arrow, and if there is any arrow event occurs, BIOS add the cell to BMC and clear the arrow status. No matter there's any error events or not, BMC will sync the PMIC arrow status with the bridge IC and to prevent the duplicate event, and then the bridge IC start monitoring the PMIC arrows. If there is any error event occurs, the error event might trigger the hot shutdown. So if it triggers the hot shutdown, big stop monitoring until the post complete next time. If it doesn't trigger the hot shutdown as a warning cast, then big add the cell to the BMC and keep monitoring the PMIC arrows. This is my code to action. Currently, we've developed these 3 new features of multi-node server management into Meta OpenBMC. And in the future, we plan to implement and contribute the code to the Linux Foundation OpenBMC as well. Very welcome to join us and discuss about the multi-node server features. And yeah, this is the end of my presentation. Thanks for all your attention.